Good morning, good afternoon, and good evening to our participants. Well, we're waiting another minute until everybody can join us before we get started. If people could just sit tight. Looks like we have a number of people coming online right now. Once we get about a minute, we'll get underway, and I'll go through some of the pre-webinar discussion, and then we'll get on our way. So good morning, good afternoon, and good evening again. I can see from our sort of chat box, we have people joining us from all over the world. I'm currently in a conference room in the USA attending an E&Y conference on blockchain and energy, which is quite interesting and sort of topical for some of the things we're doing with BIPV in terms of energized buildings. But to get underway, first I'd want to let everyone know that this event is being recorded. So anything that you do not catch during the presentation, you'll be able to get online. We'll send her a follow-up message with links to the presentations as well as to the audio recording, because today you'll be receiving an awful lot of information, a lot of content, almost a fire hose of content. So certainly there'll be a lot of questions. But in that situation, if everyone could take a look at the bottom of their screen now, you'll see a Q&A button. That's a place where during the course of the presentation this morning, you can be asking questions specific to a panelist or to the group in general. We'll be monitoring those, answering those that we can online, and others we will perhaps save to the end of the event where we'll have a Q&A, open Q&A as well. But can we just take a minute, perhaps, to just kind of get an idea of who is attending this event? If you could just test out the Q&A button and pop in there where you're from. It'd be very interesting to see what different countries are joining us today at this very, very interesting event. But to go forward, I first want to thank ATA Insights for hosting this event. This is the first and the third in a series of webinars we've been doing as ASA, which are outreach and education in nature. And this particular one is going to be very interesting, I think, for everyone here. We've had a very good response so far. And the evolution of BIPV design tools. This is a very interesting area. We have a gentleman, Philippe Amelie from InterBIM, will be one of our key speakers on this after myself and Chris give you a little bit of background introduction on what ASA is doing. And Chris, as the technical director of ASA, will give you some background on the state of BIPV and some interesting insights into that and a specific case study. And then Philippe Amelie will go in and provide us with some very interesting demo of his product. But Philippe is currently in France. He's with a team of people that are have developed the BIM solar product. But to get started, first, just again, introducing the organization here. We are Architectural Solar Industry Association. It's myself and Chris Klingo were the co-founders of the organization a couple of years ago, based in Boulder, Colorado. Chris and I, you can read our bios. I won't go into all of that, but we both have interesting experience. Chris certainly has the more technical background. Mine has been in business development, been involved in solar for 10 plus years now. We crossed paths several years ago when the BIPV was beginning to emerge in the market, and we've been working since then to get out and tell people about what's going on. And our mission, we decided what was needed more than anything about 2 years ago was to set up some sort of advocate organization, and that was the roots of ASA. We're an industry advocate for standards development, education, legislation, regulations, building and energy codes, especially as they relate to integrated solar into architectural design. Chris is going to go on a little bit more in his presentation, talk about why architectural solar, how the definition of BIPV and our definition of architectural solar sort of morph together. But we do represent a growing industry. We have representative offices, counterparts in Europe, North America, Middle East, Asia, and other markets. So this is a small but growing group of people around the world that are taking a real interest in this. I think with the advent of net zero energy buildings, or nearly zero in Europe, we're starting to see BIPV as a very significant component of building that. But our goals and objectives are to, with standards development, raise awareness, and building industry adoption. Again, I won't go through all of this. You can read the slides later because we really want to get into the heart of this, or you can visit our website and get much of the information. But some of the key architectural benefits of architectural solar is sustainability awareness. One of the key elements here, as you see from this building in the background, is when you put the integrated in design and it's viewable to the public, unlike a roof, it sends a very clear statement about sustainability and builds awareness. The idea of increased energy increases in distributed energy generation potential. I think that's an underserved part of BIPV, the lack of understanding of the amount of energy that can be produced and the payback and ROI over time from that. And the other side is with BIP it can serve multiple design intents, particularly from the architect's perspective, visually and functionally. And that's part of what BIM Solar is going to provide. It's, to date, a lot of BIPV has kind of been bespoke development. With the advent of tools like BIM Solar, it really begins to bring BIPV into the mainstream, both in terms of design, functionality, and ROI analysis. With the functionality, you've got things such as reducing cooling load through shading, as you can see from the picture here. And manufacturing installation costs can be analyzed on an incremental basis, which is a key component. That's one of the areas that BIM Solar is working on and is developing, and we'll hear a little bit more about that later. We do have a question. We're going to have 3 questions throughout the presentation. I'd like to have Araceli post one of those questions, because we hope to use the panel. And if you all could respond to this question, is how likely are you to use BIPV in the future on your future projects? Very likely, likely, unlikely, very unlikely, or don't know. If I'll count down from 10, if you could select one of those, and then we'll move on to the other parts of the presentation. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So very interesting. So we have 61% of the group. That's a very positive. Group is interested and will be more than likely to use this in the future. So just sit in your seats. We have a lot of content to cover this morning or this afternoon, this evening in your case. But I think you'll find it very interesting and compelling. We will have a Q&A session at the end, so you'll have a chance to absorb all this information, jot down your questions, post them in the Q&A box. But why is the market ready for BIPV? This is something I think people have been talking about for maybe the past decade or more. BIPV has been around for a long time. I looked at one of the first research, or I guess analysis, that was done back in the 1990s. It was funded by NREL, and it's been a topic of discussion for a long time. But what we're seeing today, much on the tailwind of solar, we're starting to see the steep cost reductions. I mean, you can't help but look at that today and what's happened with solar in general, and that's certainly influencing the opportunities for BIPV and the technology and the improvement in technologies all the way around. We're also beginning to look at it from its incremental cost, particularly as a building. I think that one of the areas with BIPV, it started out as sort of an aesthetics product, but now we're starting to look at it as BIPV is an active building material that generates electricity. So there's an incremental cost, but there's also a compelling payback that we can look at. And then in the U.S., in the case of the U.S., we have tax credits and depreciation savings, which are things people are looking at. BIPV incentives, while they're in different places in different ways, they're beginning to emerge in Europe and in the U.S. And the key thing I think to look at is that from the building owner developer, is the high lease rates and valuation. I think the market out there is beginning to take a closer look at the concept of sustainability and net zero building. So Some of the trending tailwinds that are helping this is government BIPV regulations. There are some high-level announcements being made in Europe that are starting to push an interest and incentive in this. Net zero building, the sort of topic is of the day. If you look at what the World Green Building Council is doing, and all over the world, they're connected around the globe. Their big topic right now is net zero energy or nearly zero energy buildings. Green building initiatives, you can't help but to see that happening everywhere we're involved in. And a strong sense of desire for sustainability. I think that's something that is permeating society these days, that we're all very much aware of this. And it's something that everybody wants to achieve. So with that, I'm going to pass it over to Chris. Let Chris get into some of the more technical issues that we will be covering today.
Thank you, Browning. Hello, everyone. Good morning, good afternoon, or good evening, wherever you may be. Thank you, Browning, for the intro. My name is Chris Klinga. I'm the technical director of ASA and the owner and principal of Solmotive Design. I am based in Boulder, Colorado, sunny Boulder, Colorado. At Solmotive, I help businesses bring building integrated solar projects and products to life. And over the last decade, my career has been focused on architecturally integrating solar technologies. This path has led me to you today to discuss how architectural solar modeling tools have and will evolve. Today, we'll go over how we like to define BIPV and architectural solar, the multifunctional attributes of architectural solar, and first and foremost, the evolution of PV software solutions as they relate to BIPV design. We'll go through some example workflows, and most interesting of all, we will take a deep dive into the Lumina case study, which is a great case study that will allow us to move then into Philippe Alami's presentation on BIM Solar and how it applies to that case study. We have real world data on Lumina, and it's super exciting to share it to you. So, given that you found yourself here today, and you most likely have heard of building integrated photovoltaics to some degree, since the advent of solar technologies, BIPV has been discussed. Up until recently, the definition of BIPV has been far from solidified. Today, we can look to the recent work in Europe for some guidance on the matter. But in short, BIPV is PV utilized as a construction product that provides function beyond energy production. Here you can see a great example of BIPV that some previously may not have considered true BIPV. The sunshades seen here are a retrofit application to a parabolic facade. These sunshades were applied to this building to address the fact that the parabolic high-performance glazing system was producing a death ray that was melting bumpers off of cars in the parking lot. Therefore, if you remove these solar panels, they will most definitely need to be replaced by an equivalent construction product. Where BIPV gets fuzzy is regarding what we consider a building. And the International Building Code clearly includes carports and canopies as buildings, but colloquially speaking, that is not the case. We don't think of those shade structures as buildings per se. Therefore, I think the term BIPV is selling itself short. In all instances where we utilize PV or other solar technologies as a construction product, I simply use the term architectural solar to clear up this ambiguity. Simply, solar technologies with architectural significance. Here you can see an extensive list of architectural solar applications. This list is ordered from least integrated to most integrated, with this green bar providing a sense of the energy generation potential for each application. The more integrated a technology, the higher the upfront total cost, but the more opportunity there is to reduce the incremental cost through multifunctional benefits. In the less integrated categories, some off-the-shelf solar products can effectively double as construction products. The reason I bring this up is because in today's case study, you will see a rain screen application of a standard solar solution. The multifunctional information here is also important in understanding all of the benefits that could potentially be analyzed via BIM content as software solutions evolve. So in our review, we'll go from a CAD-based input to a basic cost analysis that will be seen in the Lumina case study. To start things off, we can look at a quick history of BIPV software and how it's evolved. Since 1998, we've had an in-depth PV analysis capability with PV-Syst and basic analysis capability with PV-Watts. PVGIS came onto the scene about a decade ago, and it functions in a similar capacity to NREL's PV-Watts for the European market, but it also has worldwide inputs available. Next, the tools that take a deeper dive into specifically BIPV applications and financial analysis are right here. And some are free and some are paid. But then in the middle of the spectrum, we have these interesting programs that have not really been focused on PV per se, but more on building performance. But they happen to be capable of doing PV analysis as well with their appropriate plugins or just right off the bat. But unfortunately, these tools are somewhat cumbersome to use in a fully integrated manner. BIM Solar looks to integrate the building performance and PV performance capabilities of these solutions into an easy-to-use interface that is focused on BIPV. To add further benefit, they are focused on creating building information modeling content, or BIM content, while doing so. If you're unfamiliar with BIM, you can think of it as CAD data that is beyond three dimensions. It can include costing information or countless physical or performance attributes that drive design decisions. I would also like to point out that the Canadian government is currently conducting extensive research on BIPV software and will be issuing a report for all of these solutions comparing results to a real-world case study. So stay tuned for details on that. We'll definitely be sharing those. So now we can get into some early stage BIPV feasibility workflows. And if we just go through the first one, this is what I do typically for a BIPV installation that doesn't have considerable shading concerns, or I just don't want to look at the shading concerns quite yet. And the first step is developing the rough model in SketchUp or any other CAD platform for that matter. I then import into BIM Solar to identify the best energy generating surfaces on a given project. And I then take that information and I utilize PV-Watts. I simply enter 1 kilowatt for the DC system size, and I choose the correct parameters that are most similar to the installation. PV-Watts doesn't have detailed temperature data on BIPV per se, but the numbers that they do have are pretty darn accurate, and you can use them in these rough calculations. For instance, the roof mount array type is okay to use for a vertical facade to some degree on this rough level. If it was a canopy, I would use the ground mount scenario, so that would have a better temperature coefficient. So in the end, I really just focus on getting a kilowatt hour per kilowatt per year value for each surface. I then identify the technology and the power density of that technology by simply taking the total watts over the area of the array. I convert that to a kilowatt per area, and I multiply these two values, one's from PV-Watts and the array density, to get what I call a renewable production intensity, or an RPI. You can think of this as the EUI of solar. We don't want to call it EUI because that's energy use intensity, and this is really renewable production or energy production intensity, EPI or RPI, whatever you want to call it. And so we have a value for each surface, so we can really see how valuable each surface is from a kilowatt hour perspective based on area. And we simply multiply it by the areas that we've calculated from our CAD model to get our year one production. And then that year one production goes into a financial tool typically something like System Advisor Model from NREL or similar programs that are out there, and you do financial analysis from there. The key there is that we're entering the incremental cost of the solar solution for a BIPV system. And the key there on incremental cost is that the incremental cost is really the cost of the solar after the replacement cost of an equivalent construction product is taken into account. So this is my process that I go through to analyze BIPV. You can see how it's somewhat convoluted. There's a lot of software involved, but you can see how these platforms could all be in one solution. And there certainly are solutions out there that can do a lot of this in an integrated manner, but not all of them, hardly any of them actually focus on BIPV. So I tend to do it this way because it's the way I'm comfortable. If there's shading involved, the process is a little bit different, but it's pretty similar. Recently, I've been utilizing BIM Solar to calculate the kilowatt hour per kilowatt per year for each surface as well. PV Watch is a little quicker, but when there's near shading objects, it's far more accurate to utilize a tool like this. And the first step is to use Placemaker to get basic near shading objects put into the model. I also model other objects myself if I have better information on them, and then go through the same exact process. So on to tomorrow's BIPV workflow. As you can see, the previous is a little bit convoluted, and I'm using multiple software platforms for pretty basic calculations that could really easily be calculated in one BIM software application. In the near future, you should be able to use tools like Revit in conjunction with BIM Solar to get this same result. Today, BIM Solar is not far from this promised land. They provide a free platform for PV performance with ray tracing-based shading and analysis. In my mind, this is a game-changing detail. Typically, this is a paid service. They can estimate energy offset based on EUI approximations for certain building types. So they have a database of EUI values for buildings, and that's energy use intensity. So it's based on the building square footage. Lastly, they also have financial analysis capability, although it is currently pretty limited, and they're looking to change that. But in the near future, they are moving towards creating rich BIM content that can be used across several platforms. They will be able to also account for the thermal benefits of BIPV and its daylighting impact. Lastly, I added glare hazard here to the list in the hope that they would also be receptive to it, because glare on vertical facades is somewhat of an issue, and glare with PV systems is proving to be an issue as well for design in high traffic areas and airports. So it'd be a great add for a BIM type platform. So on to the main event, the Lumina case study. Hopefully what you've all been waiting for. The Lumina building is a project that I had the pleasure of helping design as part of the Lumos team back in 2014. And it is everybody hear me okay?
Now we can hear you, Chris. Yes, you've disappeared there for a bit. We don't see you. Maybe you can switch on your camera. We just missed you about 5 seconds, perhaps.
Okay, great.
There we go. What did you touch? Don't touch it again. All right. I'm afraid it's an internet connection thing, Browning. It might be a good idea to move on to Philippe. It's up to you.
Wait.
Let's give Chris a minute. I mean, he should be able to pop back on here. Maybe just takes his video off, and that will make it better. Chris, are you back with us?
Can you guys hear me now?
Fine. Just keep your camera off. It might be.
Okay, I'll keep my camera off. I'm really sorry about the. So, can you guys hear me?
Fine.
Okay.
Yes.
Perfect. Okay, so the Lumina case study, the main event, we almost lost it right before the main event. The Lumina building is a project that I had the pleasure of being a part of with the Lumos team. I don't know if you guys heard that, but back in 2014 or 2015, it was roughly 100,000. It's roughly 100,000 square foot multi-use apartment building. It features 20.75 kilowatts of Lumos LSX PV, and it encloses an exterior stairwell. And you should note that these are not PV IGUs; they're simply safety glazing. The Middle Eastern inspired 6 foot by 6 foot anodized aluminum cladding serves the goal of cooling the building through passive means. The tenants are allowed to modulate their units' exposure to the sun and the neighborhood through sliding screens into their desired positions. As you can see on the side here, you can see the sliding screens. These screens provide a good example in understanding the true incremental costs of the PV. Had the PV not been utilized on the stairwell, these screens could have served as an alternate. And a special thanks goes out to all these folks for providing in-depth information on the project, Lumos included. Here you can see the architectural significance of this stairwell. It naturally daylights the space as well as providing architectural expression at night. The middle image is an image from BIM Solar, so analyzing the performance of the surfaces in question. And here, this is a great image of it at night, where you really see it's a beacon in the community at night. It's a great add to the building. The rooftop was considered for PV, but since a priority was placed on extensive daylighting, as you can see here, these are all daylighting or solar tubes and daylighting skylights. So the broken up nature of the rooftop array required the architects to think outside of the box. They thought about laying out PV on the roof, but it was just far more elegant to put the PV on the facade. The system consists of 28, let me just go to next here, 28 panels on the facing southwest and 55 facing southeast, amounting to 20.75 kilowatts. The system specs are as follows: 526 square feet here, at 12.8 kilowatt hours per square foot per year, and just over 1,000 square feet and 13.2 kilowatt hours per square foot per year. I apologize that I'm not providing the metric info there, but in the end, it's 20,358 kilowatt hours per year on this system. The LSX Module Racking System is a glass backsheet product, not a glass product. It has a 6 millimeter thick front sheet in combination with its encapsulant, backsheet, and proprietary support system, which allows it to pass the safety glazing standards, even with an EVA encapsulant. And the wire management is also integral to the design, which is a critical detail for the stairwell. The 3 Sunny Boy 6 kilowatt inverters feature multiple MPVTs, which allowed for different string lengths. And the string layout and integration methodology can be seen here. These details are important for the inputs on BIM Solar, which integrate all of these things into the analysis quite nicely. The other really exciting detail is that Lumina features real-time monitoring by eGauge. Here you can see the actual peak performance of the array at 13.68 kilowatts, or 66% of the nameplate value. Yes, it is less than the nameplate value because solar never performs really in situ at full STC value. But you can see that the overall performance is in line with PV Watts' estimates. And peak performance most likely occurred in February due to cold temperatures and more direct sunlight at the peak of the day. but March is the best production month overall, and the best day within March can be seen here in the bottom figure. The higher production in the morning makes sense due to the system size being larger on the southeast portion. The PV watts estimate was 20,360 kilowatt hours for the system. In year 3, this would be derated to 20,056 kilowatt hours, roughly at 0.5% per year. The system is not degrading that fast, but that's the metric we typically use in the industry. The year to date, the system has produced 4.2% more energy than expected, but over its life, it's been down 9%. This is due to the fact that an inverter went down for roughly 1 year without anyone being alerted. This was mainly because of a change in maintenance staff. So it's an interesting detail to take note of, that inverter downtime is something that you should take into account because it will happen. And here you can see that the yellow figures represent 2016, where that inverter was down. So each of these different colors are a different year, and we're currently in the red, and you can see it's performing quite nicely compared to the blue PV watts estimate. So we were lucky enough to have true system costs provided by the solar installer, ARE Solar. They used to be AAE, but they've since rebranded. And as you can see, the system was privy to a 6 cents per kilowatt hour production-based incentive from Xcel Energy for 20 years. The electricity rate was estimated at 12 cents. You can also see that the installer did not take into account any building component offset, and the system paid off in roughly 11 years. Given that there was a clear alternate cladding system, I think it makes sense to model the value that the PV system added to the structure. We can estimate this on a per area basis. So the system area is 1,560.6 square feet, and that translates to about a $60 per square foot cost. After federal tax credit, this comes to $42 a square foot. Next, we can look to the University of Applied Sciences of Southern Switzerland, or SUPSI, for some guidance on material costs. They provided this great diagram in their latest report. Due to the lack of info on metal siding, we have decided to take, I've been able to actually add a little bit to it. So I've added a little bit on metal siding, and we believe the metal rain screen system could cost around $20 per square foot installed. That's an installed cost. So I honestly think that that's incredibly conservative given the ornate nature of this metal screen system on this install. Honestly, I think that it could potentially be upwards of $50 a square foot, but I don't have that information from the architect. We're still seeking that information, and in future white papers will be releasing those real figures. And since the figures are only approximate material costs, I've added some insight based on NREL's benchmark study to determine the total installed costs of the PV figures, because what's represented here is just material cost, and the total installed cost ranges are denoted in blue. And then just as a quick reference, where did lumina fall? The material component of lumina, meaning the BIPV system components, the things that actually make the wall, not the electrical generation side of things, but the installation labor to get the modules in place was around $38 a square foot all in. And you know, sorry for the material cost side of things, but when you add the installation, it was around $60 a square foot. And I'm not going to speak much to this baseline installation cost adder, but this is a figure that's pulled out of the NREL cost benchmarking analysis that really figures out what the true intrinsic PV system costs are, and they come out to $1.30 a watt or $1.50 per square meter, meaning these are the costs that you're going to spend on a BIPV system, no matter what. It's going to be an added cost to the system. So to determine the BIPV incremental installed cost, we subtract the $20 per square foot from the 60 to get $40 a square foot, and we then subtract the ITC based on the complete system cost. Note, you must consult your tax professional in the US whether or not you can take this complete ITC on this full cost. Given that is a gray area regarding whether or not there's true dual functionality in this particular facade, I would guess that the entire installation would be eligible. I would welcome others' thoughts on this topic. Should you be familiar with the US market, it sparks an interesting dialogue. But in the end, at $22 a square foot, you can see that this PV system is becoming very competitive when the replacement cost is taken into account. If we take this incremental cost and apply it to the solar installer's previous analysis, we can see that the cumulative savings gets us to a 4.5-year payback. So by doing this, we're just simply changing this value here to 34,000. And you can see that the cumulative savings gets in the 34,000 range in the 4.5-year point rather than breaking even down here. So it's just a simple way to look at it. We did not do an in-depth analysis. We just used the solar installer's previous analysis. And another thing to note is there's a lot of figures here that are specific to the US market that BIM Solar may not be able to take into account at this time, but they're working to achieve. So you may ask, why didn't the solar installer's analysis take this into account? I believe that the industry simply has not been educated to clearly quantify these values. It will take software solutions like BIM Solar to help guide us in that direction. As you can see, there are simple concepts that can help. These are simple concepts that can help communicate the value of architectural solar. So the market needs PV-enabled BIM solutions that can do just that. Architects and engineers need a comprehensive platform to merge CAD modeling with PV production, the countless multifunctional benefits of architectural solar. So without further ado, I introduce to you Philippe Alami, who will show you the capability of BIM Solar through the lens of the previously analyzed Lumina project.
Chris, this is Browning real quick. Can we ask, we have one more or two more questions, but one with the Araceli you could put up as we transition to Philippe. So we have just a series of questions here, but this one is, please select the most significant barrier to BIPV. And you just hit one of the buttons there. Return on investment is not clear. The upfront cost of BIPV systems when compared to conventional building materials, lack of standards, lack of acceptable products, and lack of building industry integration. Now, there may be multiple ones, but just try and select the one you think is the most significant one right now at this point. But it's just go 5, 4, 3, 2, 1, and hopefully we'll have some results here. Return on investment and upfront costs of BIPV. I think both of those things are being Chris addressed. And I think as in the last part of his statement, he was mentioning that why wasn't this analysis done by the original installer that he prepared? I think it's just a lack of maybe knowledge and understanding, a lack of available tools to do it. And that's what something like BIM Solar is moving us closer to doing. So we can have that analysis and don't make it such a mystery right now, because ROI is a kind of a mysterious thing right now when it comes to solar and BIPV, but I think we've come a long way towards that. Anyway, with that said, I'll let Philippe take over and speak from now.
Good morning, good afternoon, and good evening all. I am Philippe Alami from NRBIM and in Toulouse, France. So I'm going to present briefly BIM Solar, his features, and I'll answer to your questions at the end with Chris and with Browning. So let's talk a little bit about BIM Solar. If you can see my screen, I hope. To resume, I could say BIM Solar, the aim of BIM Solar is delivering free software to support PV architecture integration, and then afterwards to develop premium services. But first is diffusion of a free software, and BIM Solar is a free software. We are NRBIM for associated managers, engineers, and we are experts in ray tracing, energy calculation and simulation, 3D modeling, 3D interfaces, software development, and building information modeling. I guess some of you or most of you know about building information modeling. I can say some words about this. It's dedicated to building industry, of course. It's about collaborative workflows supported by digital tools and software development, and now digital platform, and a lot of data are being exchanged now between different tools, and a lot of teams around the world with more and more complex projects linked to energy, big energy issues, net zero building issues. And BIM is today the main way to gather information, to collaborate, to interchange information, and to be able to make synthesis at each step of a project. So BIM is our main driver. What is the origin of BIM Solar? BIM Solar comes from a consortium called the BIPV Insight, led by Tecnalia, who is a leader and research and technology center in Spain, and ABIM ourselves, expert in BIM and business modeling as well. Bear Architects, ComSat TFM installers, building company, and experts in BIPV installation, and I2M in Bordeaux, France, research and education, university and engineering laboratories. It was supported by InnoEnergy, that is a very important supporting center in Europe. So the question is for us how to get crucial information about solar energy integrated into building schemes. And with BIM Solar, we try to answer this question, and we bring some answers. Our issues: architecture today is BIM ready. Everyone uses a CAD tool, a 3D modeler, but traditional PV is not using this kind of tool. And BIPV, as we have heard from Chris and from Browning, is taking off. So today, project needs to meet products, and products need to meet projects, and BIM is the only way to support this. So our mission is to bridge this gap and to support BIPV with BIM innovation. Our model is product and service through the BIM Solar community, because BIM Solar is more than a tool, is a community being built today. Our product and service business model is to deliver first high performance software for free. So you will be able to use this software for free to design your BIPV system and your more traditional, even more traditional PV system. And this will support you in your early decision. But you will be able to take part to our community and to support building this community. Then building premium services is with you, is maybe for you as well, and to help designers and manufacturers to get more value, more data, more valuable information from BIM and from expertise. And then our business model is to address key players like building companies, of course, and utilities to push forward the BIPV and the solar architecture. What is BIM Solar today? BIM Solar is first a BIM software with a full 3D solar calculation, which is pretty original in this range of software. It's also a web platform and a community focused on solar architecture. It's an accelerator for early feasibility studies. BIM Solar is focused on early studies, very early steps from the architectural design to calculation. It's dedicated to BIPV, applied PV, and BIPV, integrated PV systems configuration. We talk a lot of configuration, and it's design and decision support platform to see it as a whole. Originality of NRBIM is interface, all 3D integrated and BIM. Not so many tools, not so many menus. Only one menu is used to configure from cell to glazing systems. And then you only use a 3D interface to handle your 3D model and to progress through steps on the side left bar. You will see the interface step by step in my presentation. And BIPsolar.com is a community. We are building this community because we need to offer this software, to make this software more popular, and to continuously improve the performance and add features and develop, of course, services. And this will be through discussion groups, projects featuring. It's a kind of BIM to web or BIM on the web. It's the platform strategy we have. And we're going to develop also BIPV catalogs, typical BIPV catalogs, and they don't exist today on the market, and the manufacturers need to provide them to the designers. And this is to build premium services. Let's talk about the BIM Solar software. And I will showcase the Lumina project handled by Chris, and you have considered Chris results before, of course. So all you need is a 3D model and weather data, and they are the inputs, the main inputs for BIM Solar. So from reality, you are able to get a 3D model from SketchUp, maybe from a point cloud. Anyway, just get a 3D and then start with BIM Solar. Importation of 3D models are from traditional 3D or more common 3D formats like SketchUp files, Trimble SketchUp files, but more BIM formats like IFC, in most interoperable and more standardized formats like IFC, GBXML, Green Building XML, or IDF format from Energy Plus. Autodesk Revit today is a big question, of course. Today we use the IFC generation from Autodesk to import IFC file, but we are developing through another project called PV Sites, European supported. We are developing a typical and a very focused plugin between Revit, Autodesk Revit, and BIM Solar to get more data and more features between the two software and to be BIM one way and the other. We start considering the environment and the sun path because the data, incoming energy comes of course from the sun and from the weather data, and we display immediately, instantly your location and the sun course. You will be able to import your weather file from a typical TM2 or EPW file, or you will be able to build your own file as far as you are able to gather data. And we can help you, of course, through the interface to locate your site, your project, and to select the best weather file near your project location. And it's combined with data importation, and the sun course comes immediately to show you architectural shadows. Of course, you've got calendar to study first these shadows effect, as you can see on this slide. And then you go through more settings, always in 3D, like albedo setting. As remembering, albedo is reflection. Sorry, albedo is reflection, energy of reflection from the ground, from surfaces, from ground and building surroundings to the surfaces of your project. So albedo is very important to consider solar gains and indirect solar gains to enhance your solar production. So this is easy to set into the software by clicking on the surfaces values, albedo values. And you will get more solar energy, and especially on vertical surfaces, which are dedicated to BIPV installations. Solar cache calculation is then possible with irradiance, shadowing, and direct reception calculation. We use color or shade of grays 3D display, a calendar for calculation period, and the various calculation modes from irradiance display to direction exposure with a normal precision or balance or very high precision, which need more time, of course, but nearly instant calculation process. This is the Lumina project at the city scale. Then you can see we can zoom in, and zooming in, we are able to learn about the solar energy received on every single point on the surface, horizontal surface, vertical surface, of course, existing PV surface, and to size in colors the shadowing effects. If we change the indicator to direct reception ratio, we are able to size the balance between direct sunlight and indirect sunlight, and this is useful to choose your technology as PV cells and BIPV systems. Architectural shadowing, I put this illustration to figure out the effect of the building shadowing itself, and the fact that we have put the PV surfaces, the BIPV installation on the most well and the better surfaces of the building, of the luminal building. Then we are able to go through layout configuration, selecting the best technology, the best solutions in terms of BIPV, opaque BIPV, or transparent BIPV. We can configure cell from cell to glazing system, module, of course, and even every single component of the system. And this is made from specifications, in our case, from LSX Lumos Module System, and inverters from SMA, and the wiring strategy from Chris, to get this into our configurators. Our configurators are embedded in the unique menu in the tool, and then you access very easily to the cell configurator, the glass glazing configurator, and the module configurator. You are able even to design your own cell, your pattern from a picture. You are able to draw with cells and to enhance your creativity. This was a little apart, but can be useful from some projects. And real-time calculation is always on display on the left up window of the main window of Beam Solar, and then you control your production and your primary yield, your array yield, and your losses, shadow losses, and heat losses. In the same time, you handle your PV surfaces, your BIPV solutions, and your flexibility in terms of solution, and comparing results to what-if decisions. It's a kind of what-if analysis supporting your decision. It's all about collaborative interfaces, because you can handle windows within the 3D, and then specify a change in your cell, a change in your pattern in the same way, the same time you handle your BIPV installation, and then you get the evolution and the flexibility of the results. You can also get information module by module on your layout, complete layout, about PV shadowing, the module mapping, and the real-time calculation at module level. This is always in the 3D. Then inverter configuration and wiring configuration is possible. You select from database. We embed the Photon database with more than 42,000 references for modules, and more than 5,000 for inverters. We embed this database to help you select the good and the right product, but you are also able to configure, to set up your own module, inverter, and wiring system. And this is made through the interface. And then you can handle the result by having the wiring strategy displayed in 3D and some automatic modes that enable you to go very fast first to go to your early feasibility study. The automatic mode for wiring, of course, is not the perfect expert mode, but it saves a lot of time. And then you can handle your manual wiring strategy. And we did that with the Lumina project. As you can see, every layout is able to be connected to the inverters. We have 3 inverters, and the MPP are connected through the strings to the modules. And we respect the real installation, and then we can go to results. And the results and the reports are displayed through graphs and are able to be exported in CSV to build your own report. You can get a lot of results, combine them, compare even them from monthly to hourly step time. And this is pretty useful for your reporting, of course. You can get the values from Radiance at module level, at layout level, at inverter level. You can compare them layout by layout. You can get results in terms of production and losses as well.
Philippe, real quick, Philippe.
It's a bit quick for the display, sorry.
A quick question came up on whether or not you had module electronics capability, such as optimizers.
No, we don't have optimizer in this free version. We are working on optimization in the actual research and development project, European project. There is not optimizer. There is for wiring and inverter. It's a selection of the best solution, the best existence of an inverter in the database fitting with strings and the module, the layout. But it's
okay,
not.
Yeah. So, but do you have plans to add optimizer capability? Because that is something that's taking hold in BIPV specifically because of rapid shutdown requirements. And the ability for the modules to be more shade tolerant. So I honestly think it would be a great addition to your software, and you should.
Yes, it's a great issue. Yes, yes, we have plans. We have plans to reinforce the relation between inverters and modules because the science is there and there is research to do. So yes, we will do it.
And then another quick question. There's two that popped up for you. What's the relationship between PV sites and BIM Solar?
PV sites is a project today. So PV sites, it's a European project. PV sites, not PV system, of course. PV sites and PV sites uses BIM Solar as data as basis for software platform, and will enhance performance of BIM Solar with manufacturing capabilities, with project.
So it's a collaborative. It sounds like it's a collaborative effort between PV sites and BIM Solar. BIM Solar is providing the software solution to PV sites, and PV sites is potentially providing you with manufacturing information.
Manufacturing, yes, manufacturing innovation and product innovation like thin film and transparent module, new modules from Onyx Solar, for instance.
Great. And then the last question that's here is, do you have an interface from CAD to CAM? Meaning, if you create your own panel, could you send that data to a stringer or a layup station? And I can probably answer, but I'll let you.
It's on the roadmap, yes. It's for a future project, which could be called the beam to manufacturing with BIPV. Of course, we have a lot of questions about manufacturing because it's a big issue for manufacturers. So we're gonna, yes, if we win the next project, we'll be able, of course, to develop the specific model and optimizer from beam solar to manufacturing software to translate the beam data to manufacturing data. And then the link and the bridge will be built, of course.
Great, you can move on then. Sorry to interrupt.
I think there is a very long roadmap, of course, linked to the BIPV, market uptake and innovation. So through the results, you can get, of course, monthly results and 2 hourly results for production and production losses by shadows and DC production and losses, of course, of DC production at inverter level, losses by temperature, losses by mismatching. And this is instant, so you can compare your options, compare your layouts, compare your inverters, and then well balance your system, of course. And then we get to the financial analysis, which is very simple. I have to say it's very simple today in this free version, because it's the first version for beam solar. It's a free version, so we have comparative strategy, but very simple and at European and maybe very French level, because we have feed-in, self-consumption, and mix between feed-in and self-consumption strategy, which is not used everywhere in the world, of course. We should ask net metering, of course, but this is not a big issue for us. It's a lot of improvement, of course, but it has to be developed and to be connected to other tools, because our target is not, and our philosophy is not to put everything in the same software, but create connections to specific software, like maybe Enrail SAM software to run feasibility studies. In this financial analysis, what we get is the possibility to integrate, of course, PV system costs, which is the CapEx, maintenance cost, which is OpEx, and in this use case, the Lumina project case, we try to put the right information in the system, the right cost, and then to get the payback period, which is in instant simulation 5 years, in feed-in or feeding is used to here like net metering. So we are not too far from trace results, and this can be good for a very rough evaluation, I would say. But you can then twist to self-consumption strategy, and then you could get an idea of what could be the consumption level in connection with your production, and this is a good way to start a real and deep feasibility study. So just remember, this model, this step is a very rough and very early step for feasibility studies. We will develop a specific and a premium feasibility and financial model through connections. What are the other use? Maybe for beam solar, city scale. I would insist to city scale because our technology enables you to run and to calculate solar energy at the city scale in terms of irradiance, shadowing effects, and even very rough layout studies. So this could be used using, for instance, placemaker, when with what you can get a 3D model at the city scale, at the district scale, and then you can very quickly run a study with beam solar. Then let's go to the web, because BIM Solar enables you to upload your project from the software to the platform. And in the platform, you will find your project in the BIM Solar web mode, and then you can recall your main figures. You can display in 3D on your iPad, on your tablet, of course. You can share it. You can showcase, and this is important for us in terms of disseminating and initializing the business model. So connecting to bimsolar.com web platform enables you to meet people also, and then to start discussions and find expertise. We're going to develop services and a lot of relationships within bimsolar.com. Coming soon, we have talked about the roadmap, but coming soon will be first the Autodesk Revit plugin, because this is, of course, a huge part of our strategy. The plugin is, of course, complex to develop, but will enable importation of on the way on the 3D model, of course, with a lot of details, but not too much, of course, because the more details you get, the more heavy is calculation. But this will be able to get the information, the BIPV information from BIM Solar, and then to send them back to Revit on the way back. And this is very important for the BIM innovation, because we will be able to select and to configure Revit families of new BIPV objects within the main BIM solution, which is today Autodesk Revit, and which is used as the pillar of the project. And the user will find their product, their configurations into Revit directly from BIM Solar. Second step will be Energy Plus connection, because BIPV is about thermal impact and thermal comfort, and we need to provide information to Energy Plus models, and we have studied specification, and now we are developing this within the PV sites project to provide an update of your Energy Plus file with the BIPV information. And then you will be able to get the thermal figures, thermal balance updated, and thermal comfort informations. Daylighting is also a very big issue. It's our technology. We are able to develop this, this module, and this module will come from the needs of the manufacturers first, and from experts to provide sustainable studies. Report Builder is missing today in the free version. It will be developed for the premium version. And of course, the catalog, new catalog, what I call e-catalog of objects. It's more than a database. It's a BIM-ready library coming from manufacturers and able to share information in BIM mode, instant time, real time, through a web platform and the BIM Solar web platform. And this is called a Product Information Manager. So this is coming soon. As a conclusion, I would say we are enabling net zero adoption, because we are able to provide more and more information like metrics for LEED and other sustainable studies. We provide time saving, of course, because our focus is on early stage of the feasibility studies, and we provide a lot of information quickly, and this helps save time and get accuracy at these early times. Free shading analysis tool for PV production was missing on the market in 3D. We made it. Now it's easy to use, and it will be, of course, improved a lot in the next years. Focusing on architectural surfaces is the target for BIPV and solar architecture. We do it, and today integration of in 3D, in virtual, of 3D BIPV system is made possible through Beam Solar. So just use it and just create your system. And then validate incremental cost of architectural solar and quantifies multifunctional benefits. This is what Beam Solar enables. Flexibility of Beam Solar, of course. In the use case, we have been able to calculate the same system, not in BIPV, but in BIPV, and the results are comparable. And this is the flexibility for Beam Solar. You can change your strategy and you don't lose time, but you save time because you are very fast in reconfiguring your layouts, your products, and your strategy for your feasibility study. So just connect, just visit beamsolar.com, of course, and just ask questions because this is the beginning of a long story.
All right, Philippe, thank you very much. And I want to tell everybody who's been online, we've gone a little bit over time here, but it was important that we capture all this important information and the evolution of BIPV. And I applaud Philippe and his team for what they're doing because it truly will bring BIPV and awareness of BIPV and utilization to its next step. But before we close out, we have one last question, if we could just post it very quickly. For those that have further questions, you can certainly contact BIM or send it to info@arcsolar.org. We do want to engage you as much as possible.
Browning, we will address the open questions before signing off today.
But okay, so one last thing, just real quick, you can see on your screen, what is the reason to use architectural solar BIPV in your particular situation to raise energy awareness of building patrons, to obtain an ROI from electricity generation, to showcase corporate social responsibility, to help market the building to clients and customers, or finally to achieve LEED certification or meet net zero standards. So if you could just collect one of those in 5, 4, 3, 2, 1, and that's the end of our questions and Q&A. So, okay, raise energy and to obtain ROI. Okay, well, these are certainly things that, that BIM Solar and Architectural Solar Association are working towards achieving. And we want, for those of you online that don't know that much about us, we encourage you to contact us. But Chris, if there are some other questions you want to answer before we part, I do want to thank Philippe and Chris and ATA for their support. And this will be continuing to have these outreach and education webinars. And this will be will be mailed out and sent out to you, a link for the recording and the presentation. So with that, I'll let Chris and Philippe, if you have anything else.
Yeah, I just wanted to address the 3 open questions that are out there. Philippe.
Yes, of course.
On the technical side, the shading analysis, is it on a module basis or on each string? And if it's on a module basis, can you specify diodes per module? What is the granularity of the shading analysis?
Shading analysis at irradiance level, it's on every cell, not for production analysis, but for irradiance analysis. But for shading analysis to production, it's at module level today. At module level.
It's a module level, but you don't specify the number of diodes per module, correct?
Yes, we specify the number of diodes per module, yes. It's embedded in the configurator and it's also in the photon database with the module references. So,
okay, so if you reduce the number of diodes, the shade tolerance will go down.
Yeah.
And your performance will go down. So that's pretty interesting. And then Silky Krawitz had a question regarding which company for BIPV are you connected? As you mentioned that the BIPV modules can be designed individually. So I think she was just asking, who are you collaborating with maybe? Because you're obviously an independent software solution, but you collaborate with some manufacturers. And I know that you have multiple cell manufacturers in your database. So you collaborate with all the manufacturers that are in your database to some degree, but do you collaborate with some manufacturers specifically?
Yes, of course. We are involved in European projects. So we collaborate with Onyx Solar today, Flesom in Switzerland, within the PV Sites project. You can consult pvsites.com.eu, and you will find information. So we use Beam Solar as the basis to enhance performance for manufacturers. So Flesom, expert in thin film CIGS models, tiles, and cladding systems. And Onyx Solar, of course, for transparency, hidden boost bar, and back contact cells for new models. And larger, we collaborate openly with any manufacturer, of course, because we receive a lot of questions, they test, the challenges, and we improve the knowledge. And this is very new because the software is recent, and BIPV in Europe is at the early stage. There are a few leaders, but some new companies like Sunpartner Technology in France for BIPV glass are emerging, and they are collaborating now a lot with us.
Great. And as far as the technologies go, you currently in your BIPV side where you can configure your own module, can you add thin film technologies, or are you limited to crystalline? You can do CAD-TEL, anything really, or is
yes, anything. Yes, we have anything. Amorphous silicon. We were discussing yesterday through a webinar with Onyx Solar with amorphous silicon catalog, of course, and we will produce a specific catalog of Onyx Solar products within 4 weeks, I guess, with amorphous silicon transparent glass, and this will be interesting. Getting this through Beam Solar, it will be free, so users can be able to experiment this.
Great, great.
And with Flesom, it's about CIGS, and CIGS seems to well behave on facade. We have use cases, real buildings being installed this month, so we will be able to provide comparison between simulation, calculation, and prediction, and real monitoring results on real installations at the end of the project next year, end of June 2019.
Great, great. Well, hey, thank you so much for your time, Philippe.
Thank you very much.
It was a really informative discussion. I hope all the participants felt the same way. If you guys have any questions, feel free to email info@arcsolar.org or Browning or I's individual emails. And we look forward to the ongoing dialogue and future webinars on this topic and many others.
Yes, thank you, and good night or goodbye, good afternoon to everyone. But stay tuned, we'll have more information forthcoming.